labs.
Glutination. Oh, all the tests we've done in lab.
Which ones?
All the EIAs.
It's like putting 2 drops in. How long do you wait after those 2 drops?
I'm not going to ask you time, but I'm going to ask things like RSV. Where is the antigen? Where's the antibody? We did RSV. I
gave
can
us
see
a
what
sheet.
One of them's
Okay.
given in the test. You know that.
What's
One of
that?
them's on the card.
That's good. So you got a 50-50 shot, right? The RSV is the antigen. Remember, I told you the one time you can pretty much be sure is if the specimen is not blood, you're almost always looking for the antigen. I can only think of a very, very rare occasion where that's not the case. So if it's a not blood specimen, you're pretty much looking for the antigen.
We wrote it down.
Now, if it's a
I think I
blood
wrote it
specimen,
down.
it
2 days
could be
ago.
either way. But I think the test we did in here, aren't all the blood tests we did in here antibody tests?
So the RF is, I mean, it's.
The RF is
Yeah,
antigen, you're right.
antibody.
Got it.
The
That's the only one,
mycoplasma.
every one of them. The other ones that use blood, they're antibodies.
50 points?
Hundo.
50 points or 50 questions?
Did you get it?
Chris?
What's on the test?
50
What?
Did you get
I
it?
do
Yes.
believe we already reviewed a little bit, so I'll try to remember exactly the things I said before.
No, just the PowerPoint.
Oh, the PowerPoints, it's
Glutination.
agglutination, precipitation, latex, labeled immunoassays. But I also gave some other notes in class on that stuff. Remember we talked about, and the stuff I gave in class is actually on those PowerPoints as well. We just went over it more than one time and kind of from a little different angle. So make sure that you know, so we've got precipitation, agglutination, and label and enzyme testing. Okay. You need to know competitive assay versus non-competitive. Let me put it this way, as far as the essay questions, there's gonna be a lot of drawing. I will take pictures. So like if I say, describe a competitive assay test, or describe a non-competitive assay test. If you wanna draw me a picture, I'm good with pictures. You guys seem to be doing really good on the picture ones. Okay, so if you wanna draw me a picture, that's okay, you can draw me a picture. I can pretty much guarantee the sandwich technique is going to be one of the essay questions. So I pretty much think you need to be able to draw the little pyramid of antibodies, okay? Don't forget to put the tag on it, because if you don't flag that last antibody, you can't see anything. Competitive assay, non-competitive assay, make sure you can define prozone. And understand what prozone is. That one, if you want to draw a picture for it, that's fine. But basically, prozone, I can tell you pretty much it's going to be an essay question. What is prozone and why is it significant to testing? Make sure you're all answering the second half of these essay questions. A couple of you missed points on this last test because you didn't give me examples of cytokines and lymphokines. And a couple of you, I had marked them wrong to begin with, and then realized that I was just looking for the name of one, but you explained what they did, so I backtracked and gave you credit. After I realized that after 2 or 3 of you did the same thing, and I'm like, oh, okay, the question wasn't clear enough, so I went back and gave you credit. Okay, make sure you can describe prozone, be able to describe a competitive versus a non-competitive. Be able to to tell me what sensitivity and specificity is. What is blah, blah, blah. What is the difference between sensitivity and specificity?
Sensitivity has to do with,
Specificity is
Easily
direct
defined.
organ or whatever, or direct test thing. It's
Sensitivity
testing.
would be screening, right?
How much?
That's the next
Sensitivity
question.
is
Oh.
how-
So what is sensitivity?
The ability to find it.
The ability to find it. How much of it has to be present so I can find it?
Not a lot.
Well, it depends
Well,
on the
that
test.
depends on the test.
Oh.
There are some tests that are very sensitive, and there's some tests that are not. Okay? So we want tests that are sensitive, obviously, but sometimes life ain't perfect. So sensitivity is how strong of a case does the patient have to have? How much of what I'm looking for has to be in the patient for me to find it? What is specificity?
Confirmative.
Ability to determine.
Where it's from, what it's from.
Determine what?
Exactly what antigen or
Exactly
which
what antigen, that's
target.
exactly what I need. That one particular antigen, okay? So sensitivity is how much has to be present so I can find it. Okay? And yes, that is what's most important in a screening test.
for sensitivity.
Specificity, yes, sensitivity is most important in a screening test. So, would we like every test to be 100% sensitive and 100%, okay, 99.9% sensitive and 99.9% specific?
Yes.
Of course we'd love that. Is that real world, is that affordable real world? No. Yeah, if I'm willing to pay $1 bazillion for a test, yeah, I can get that. But I'm not paying $1 bazillion a test. I have to make it reasonably affordable. So when I'm looking at testing, I've got sensitivity and I've got specificity. If I'm looking for a screening test where I'm going to be looking at anybody who might have it, I want to make sure that it's very sensitive. I'm willing to sacrifice some specificity to get the better sensitivity. When I'm looking at a confirmatory test, what I'm looking for is I want to make sure that if I tell you you've got HIV, you've darn well got HIV and not something sort of like it. Okay? I'm willing to sacrifice some of the sensitivity to get that specificity. Okay? And it's just a balancing game between the two. So sensitivity is most important in screening tests. What kind of false results is that more likely to lead to? False positives or false negatives?
For which one?
Sensitivity, if I have a highly sensitive test, am
False
I likely
positive.
to have more false positive or false negatives? And I heard it said, so just repeat it for me.
False positive.
Negative.
False positives. If I have a highly sensitive test, I am more likely to have a false positive. Because it's not specific.
It's gonna get things that are like it.
It may grab something that's like it. Okay? A highly specific test, however, which that's going to be in my confirmation tests. And which is it more likely to give me? It's more likely to give me false negatives. So when I am looking for a screening test, I want to make sure that I catch everybody who's got it. I want 0 false negatives. Okay, I know that that's never possible. But I don't want false negatives. If I screen you and I say that it's not reacting, you should be able to feel confident that you're okay. In a specific test, in a confirmation test, I don't want any false positives. If I tell you you've got it, you've got it. I would rather miss someone who has an early case or a low case, or one that's not strong enough for me to pick up yet, and retest them at a later time, than to accidentally say you've got this disease when you don't. Does that make sense? There will be several questions on that. Okay, confirmation versus screening, specificity versus sensitivity. Okay. And if you read any of the package inserts on any of the tests that we've been doing, every single one of them has a section somewhere that tells you what the specificity and what the sensitivity is. Okay. as
There's-
monoclonal antibodies have gotten better and our testing has gotten better, our sensitivities have gotten a lot higher. Some of the serology testing from the 70s, 60s, 70s, and 80s had a sensitivity of about 70%. Okay? Most of our tests today, we wouldn't even market it, wouldn't even use it if it's not at least 90. Now, there are exceptions, but there are still some things the doctor just has to recognize the symptoms and treat you based on the symptoms. We don't have a lab test for everything. A lot of stuff, but not everything. Okay. So, competitive assay versus non-competitive, prozone, precipitation. She asked you a question yesterday that you weren't able to answer, so I'm going to ask it to you again today. What are we looking for? And this is actually true in agglutination testing as well. What am I looking for as far as the ratio of antigen to antibody? What's that sweet spot called?
Zone of equivalence?
The zone of equivalence. Give me an example of a precipitation reaction that we've done. The octolony. Speaking of which, before we go to lunch, we will read that. Well, we can read them when we get back. All right. Give me an example of an agglutination reaction that we've done. There's several of them. The RF that we did. What else? The D-dimer, the cold agglutinin. Give me an example of an EIA test that we've done.
Strep, H. pylori.
Strep. You guys did pregs, okay? What else have we done? Flu. Drug test. So we did a bunch of those. What type of test is the ANA? We've talked about it. We didn't do it. We will be looking at them later, but
Direct. It was an indirect. Oh, was it indirect? 'Cause
it's a
got the-
fluorescent antibody test.
Oh.
Okay. That particular one
Oh,
is
yeah.
an indirect
Indirect, yeah.
fluorescent antibody test. Okay.
Because you need the tag.
But it's a fluorescent. And what's the name of the dye that they use? Fluorescein. Okay. What is attached to in an EIA test? What is attached that visualizes it for us? An enzyme. And how do we see that enzyme? What does that enzyme do?
Changes color.
It makes a color change in our substrate. So the last thing we add into our EIA test, and we'll be doing it today, is our substrate. And that is what the enzyme is going to act on to make a color change. How do we visualize in an agglutination? What particles do we use in an agglutination?
Latex.
Latex is most common. What else could we use? Red blood cells, and what's the other one? There's one more we talked about. Because we won't see it till we do our PRs on Wednesday. Charcoal. Okay, charcoal. Most commonly these days we use latex particles. And what does the color of the latex particle mean? Absolutely nothing. It means some guy liked red. Blue was a special today. But when we're doing the test, what significance does the color have? So what do I do so I can make sure I can see the clumping? My background. Right, to be able to see the clumping, I have to have the correct black background. So if I have a white latex, what am I going to do it on?
Black.
Probably a black. If I have a red or a blue,
White.
it's probably going to go on white. Yellow?
Black.
Black probably, but it kind of depends on the shade of yellow. So, basically probably going to try that way. I won't give you yellow as an option. But what color of the background that we're looking on? Know some things that can affect the testing, serology testing. What things can affect serology testing?
Scratching latex card.
Okay, scratching the card. What else?
Overfillings.
Overfilling. That's prozone and postzone. Okay, being out of the zone of equivalence. What else can affect serology testing?
Temperature?
Temperature. I actually think it's too cold in here to do this test today. We're gonna try it anyway. Okay, temperature. Okay. Procedure, if you screw up the procedure, it's not gonna work right? If I forget to add the conjugate, what's gonna happen to my reaction?
Nothing.
Nothing. Which reaction did we do that was an indirect EIA test? We've only done one. Yeah, our Michael pylori test. Yes, the mycoplasma test that we did. Okay, that was our indirect one. How do I read an agglutination test?
Look for clumps.
I look for clumps, but let me get this. How would I describe them? How would I report them if I wanted to give a semi-quantitative? If I don't want to do a titer, I just want to give a relative reaction strength. How would I report them? Hmm?
Positive?
I'm going to report them as 1+, 2+, 3+, 4+. How strong the reaction is. Okay. So I can grade the reaction 1 to 4+.
Is it like you're still seeing a cloudy background, but you're seeing a couple clumps in there?
A 4+ means I got one big hunk of chunk.
Okay, so how large the
A
clumps
3+ means I got a couple big hunk of chunks, but the background is clear. 2+ means I've got quite a few moderate to small size clumps, but the background is mostly clear. 1+ means I've got some fine agglutination and the background's still a little bit cloudy. I will not ask you to describe those. It's just that when you hit, guess what class?
Blood
bank. Okay, you're gonna grade the reactions. So I need to make sure that I put that.
You said that's qualitative?
It's semi-quantitative.
Semi-quantitative.
Yeah, it basically just gives an indication of strength, okay, of reaction strength. If I wanted to quantitate an agglutination reaction, what would I do? You guys did it.
Dilute.
Titer. I'm going to titer. EIAs can be quantitated by measuring the strength of the color, okay, either visually or more commonly if we're doing a quantitative EIA, we're going to do it on an analyzer. In a competitive assay, a stronger color would mean a higher result or a lower result? More in the patient or less in the patient?
Less.
If it's a stronger color, I've got a low result because there wasn't a lot of patient to bind, so there's lots of space for my tagged antigen or antibody, okay? So in a competitive assay, if the patient had a high value, what would my color be?
Very pale.
Pale. It's going to be pale. There's not going to be a lot of it because my patient antigen or antibody is going to take up all my binding sites. Okay, that's in a competitive assay. In a non-competitive assay, if I've got a really high, strong positive in my patient, is my color going to be stronger or lighter?
Stronger.
Stronger. So in a non-competitive assay, I've got a direct relationship between strength and increase in color. And in a competitive assay, I have an inverse relation between color strength and the strength of the patient's infection. Okay. Anything else you want me to ask on this? Obviously, you have to be able to draw the little octolony things. Okay. I've been practicing all night. I've been practicing doing like Jean did it, so I'm ready. So I'm ready next year, so I don't have to rely on her to do it. Because last year I tried to explain it. I was very confusing. I confused me. So you have to draw the octolonies. See if there's anything else. else I can think of.
Avidity and affinity.
Avidity and affinity, thank you. I did forget to include that one. What's the definition of avidity?
Is the sum of all attractive forces.
Okay. And what is affinity?
Initial attraction.
Initial attraction. So remember, the affinity is, ooh, that's a cute guy. Avidity is, I get to know him better, and there's a lot of things that attract me to him, not just that he's cute. Okay. I think that's quite a bit to go on. We'll be talking about, like I said, antigen versus antibody. You have to know for the test. And I don't remember what test I listed on the board. You all have those. We did those on what day? Monday or
Someday.
Friday.
wasn't Sunday? I wasn't here on Sunday. I listed them on the board, all the tests that we've done in class. Okay, so there will be some questions on those. Yes.
I want to ask a question. I want to ask, do I have the right stuff wrote down for direct antiglobulin and indirect antiglobulin?
Okay.
So I have that both of those, that blood bank does those.
Right.
And I know direct doesn't do those. What was that again? I'm sorry.
When I'm looking for the paraproteins, the excess immunoglobulins that would be present in multiple myeloma and Waldenstrom's, I'm going to do electrophoresis, and I'm going to look in the gamma portion of the electrophoresis plate, and that's where I will find my IgG, my IgM, or my kappa and lambda chains.
Since we talked about it today, do we have to know about the P24 and Western blot? No? Okay.
Just know that Western blot's the confirmatory test for. It's not something you're gonna be doing, so, but you are gonna need to know it's a Western blot. I'll hold off on the how many antibodies have to be present to call it a positive till the next test. There's lots, I can think of like a gazillion questions I could ask, but they're all pretty much related, so. Homogeneous and heterogeneous.
Yeah.
Heterogeneous, whatever.
Lattice formation.
Okay, that, I didn't ask, what can affect agglutination reactions? What solution, and I went over this the other day, so I wouldn't feel guilty if I put it on the test and hadn't reviewed it today. What type of solution do I use to overcome the electrostatic charges? Low ionic strength saline. Or low ionic strength solution. So you need to know what LIS is. Like I said, I'm just trying to help Barb out here.
You said that. Whoops.
You have to draw the
Yeah,
octolin.
that crap. Okay.
You have to be able to draw the
Thank
octolin.
Is this stuff too?
All right, I'm going to go